let's continue with another problem that also involves some dependencies among the variables. So in here we have a printer, and this printer prints mailing labels. And the first line in this label is the name of the person. And the software builds the name of the person based on the first name, the middle name, and the last name. And each of these 3 fields can hold up to 30 characters, but the whole label can fit up to 70 characters wide. And our program should return basically the length of the name of the person once the 3 names are combined together. So let's analyze the variables. We have the first name, the middle name, and the last name. They are all integer, and their ranges are, and that I'm assuming because this is not in this specification, so I'm assuming that everybody has a first name, that's why from 1 to 30, but not everybody has a middle name, so it's optional, and also not everybody has a last name, so also optional there. This is a good example of how testing can also guide requirements a bit. If you as a tester, you found this question, which is not in the requirements, maybe you should ask some stakeholder to get some answers. And here I'm going to take these assumptions. And we also have the output length, which is an integer, and it ranges from 1, there's always at least 1 character, to 70. And we have this dependency, so fn plus mn plus ln should be smaller than or equals to 68. I put 68 because maybe the program wants to print a space in between the names. And of course this could be more complicated because you're only going to print space if you have a middle name, for example, or 2 spaces if you have both middle name and surname and blah blah blah. It's up to you to make it a little bit more complicated, but I'm going to simplify here and just say that the restriction we have is that the length of the 3 fields should be smaller than or equals to 68. Let's go to the equivalence partitioning and boundary analysis. And what I'm going to do here is first I'm going to analyze each variable separately, and then the restriction together, yeah? So for each variable, for example, first name, we have the class that emerges out of the range of that input, so from 1 to 30. And so this is the equivalence class. We can do the boundary analysis, so 1 and 30 are the on points, and 0 and 31 are the off points. Great. And I'm going to introduce here what is an invalid class. So we were playing with strings before we played with integers and floats, and they also have their problems, of course, but let me focus on string for now. So the person is inputting some string there, a name, and we know by experience that software tends to crash, for example, if the name of the person has an accent, or if the person is using some letter in an alphabet that we are not really dealing with. So there are so many possibilities for a string to be invalid that maybe we also want to test for those things, right? That is why I put this invalid string there. In real life, it can be more than one, right? Maybe one test for an accent in a letter, or for you trying some Chinese character there that maybe will crash the software, so on and so forth. For now, I'm simplifying, just putting invalid string as this generic class that would fit somehow them all, okay? And that repeats for all the other 2 variables. So for the middle name, from 0 to 30, 0 is our on point, -1 is the off point. I'm putting it here, but I'm not really sure if we can pass a string that has -1 of size. I don't think so. If you're doing unit testing, maybe in an embedded system, you can somehow force the memory space to do some horrible thing there. But so I'm gonna leave this here. And the same for the last name. Yeah, great. And now the restriction. So the fn plus the mn and the ln, we know that they have to be within these boundaries. So this is not an invalid class. Yeah, so, and if I look at this, I see a boundary, so 68, the on point, and 69 being the off point. Great. So let's focus first let's derive the test, and let's focus first on these, the variables in a separate manner. So we have 8 partitions, right? 1, 2, 3, 4, 5, 6. Why did I put 8? It's 6. So it's 6, and this is 6 times 6 times 6. That I'm going to use my Mac to calculate, which is 216. And that sounds a bit too much. Didn't I change it? Yeah. So that sounds a bit too much. We don't want to write 216 tests. I'm not sure if it was clear how this number came from. So if I have these three variables and I want to combine them all, right? So all the possibilities that I could have, then I have 6 here, 6 here, and 6 here. Then this would be 6 times 6 times 6. Too much. I don't want to do this. So the first thing we could do is to not use the invalid strings in all the combinations. Yeah, that would reduce a lot of comparisons. So that would be now 5 times 5 times 5, which is, and I'm going to use the calculator again, 125 plus 3 tests. So we're going to have one test for invalid string in first name, one for the middle name, one for the last name. So this is 128. That's definitely way better than 216. But maybe what we can do is to then focus more on the boundaries themselves, right? And not combine them all. And look at them as really if they were independent from each other. So I'm going to test these 4 boundaries, and I will use just in points for the others. And then I'm going to test these 4 boundaries for the middle name, and then use in points for the other variables. So this would give me 4 for the first name, 4 for the middle name, 4 for the last name, plus the 3 invalid string cases, so 15. Great, so I have 15 tests for this part of my equivalence table. And the tricky thing, very similar to what we had to do in the previous exercise, when choosing the endpoints, we're going to choose an endpoint that actually meets the constraint that we have, where first name, middle name, and last name should be smaller than or equals to 68. That's great. And now let's investigate this restriction in particular, because I think it also deserves some testing. So this is the restriction that we have, and we have the boundaries there as well. So 68 is the on point here, 69 is the off point. So I think that deserves also 2 extra tests. So we had 15 before, now we have 17. And this is what the tests could look like. So the 4 boundaries for the first name, the 4 boundaries for the middle name, the 4 boundaries for the last name. Maybe those -1s here can be removed, right? Why not? Then the 3 for the invalid strings that we're going to exercise. And note that the endpoints that I choose are always endpoints that make that constraint to be always true, right? I don't want to mess with that constraint right now. And then finally the two last tests for the constraint. And I had to choose numbers, and I decided to again go middle range. So I tried to find the combination of numbers that would kind of be in the middle for all the 3 variables. And basically what I did was I divided 68 per 3. I saw that it's 23 or something, and then I put 23, 23, 22. So this is precisely 68, and then, which is a valid thing. And then the other one where we aim at 69, and then I just put 23, 23, 20, 23. Yeah, so these are the 2 tests for that restriction. Of course, and I'm going to show it later, maybe because you have this restriction, you can try to see this as a mathematical function, and you can try to actually plot the area and then choose many other points there. That is one option, but I don't think it's really necessary for this problem. Okay, let me see. That's it.